Welcome to Study Loop.
Okay, so this is a very lengthy problem. First, so we have this circuit here, and as you can see, I have marked all the currents that's passing through each resistors. Now, I mark the current with the value of the resistor I mark the current corresponding to the value of the resistor. So for example, I6 is the one that's passing through 6 ohms, I12 is passing through 12 ohms, I6.8 passing through 6.8, and so on and so forth. And now we see we have 5 unknowns, so we need 5 equations. Now we can use junction rule at A and B, and then we can use loop rule at left, middle, and right loop. So let's first apply junction rule at point A and B. So at point A, we see that I top is going away, I6 is going away, and I5 is going into the junction. So that means I5 should be equal to I6 plus I top. Similarly, in this junction, I top is coming in, and I6.8 is coming in, and then I12 is going away. So that's what we wrote here. And if we actually solve for it, if we actually substitute I top from both of the equations, we get a relation between I5, 6.8, 12, and 6. Right, so that's all about junction rule. Now for the loop rule, what we are doing here is first we're starting with the 7 volts here. So these two are in series, so that's why we add them, and we are taking our direction of current as clockwise. And similarly, we are taking for the middle one, we are taking the direction as clockwise again. And for the right loop, we're taking the direction as anti-clockwise. Right. So here, as you can see, we're adding 12 and 5. So we have voltage gain on both batteries. So that's why we have 17 volts and there's a plus sign. Then the current is in the same direction as the loop. So that's why we have a negative sign, and then we have I5 times 5 ohms. Then we have negative I6 times 6 ohms because of this current. So that's our left loop. For the right loop, we have two batteries connected in series, and then we have a voltage gain. So we have 10 volts. Then I12 times 12, and there's a negative because of the same direction. Then again, 6.8 is in same direction with the loop's direction, so it's going to be 6.8 times I6.8, and there's a negative sign. And for the center loop, we see that I6 is in opposite direction with the loop's direction, so sorry, it's gonna be the opposite. But it doesn't matter actually, because since there are only two currents, we'll have the same expression. But anyway, so we see that I12 is in opposite direction with the loop's direction, so that's why it's positive, and I6 is in the same direction with the loop's direction, so it's negative. But we are not considering this I top current here because there's no resistor, so that's why there's no voltage drop. So we don't have to worry about that. Right, so now we have technically 4 equations. So we have merged this equation into one. So that's why we have 4 equations. Let's try to solve them. So we start with the fourth equation. So you see it's the shortest of all. So we get a relation between I6 and I12. And then we can use this and substitute I6 on the other equation. So that's what we did. So when we substituted all the I6, we got expression like this. So these are our new equations. So these are the 3 new equations that we have. So we got rid of our fourth equation. Now what we can do here is from there we use equation 1, or the first one, to eliminate I 6.8. So now our first equation is this. So we are eliminating 6 point, yeah, we're eliminating 6.8 from the first equation. So we're writing it in terms of I12 and I5. So, right, if we substitute back to I2 and I3, we get these two following expressions. And okay, so this thing is going to be 0. Right, so then this is our third equation, this is our second equation. Now we see that we only have I5 and I12 on both of the equations. So what we did here is we now found an expression for I5 from the second equation. So as we see here that we got rid of our first equation. So now from the second equation, we write I5 in terms of I12, and we substitute that in equation 3. And if we do so, we'll have only I12 term present in this third equation, and then we can solve for I12. So that's what we did here, and then once we put all the numbers together, we got I12 as 0.6798 amps. Now, since we know I12, we can figure out I5 by this expression. So, and we got I5 as 1.768 amps. Again, we can go back, and since we know I5, we know I 6.8 by this expression over here. So that gave us this. So this is 0.2714 amps. And then finally, if we use this expression back here, that gives us the expression for or value for I6, which is 1.36 amps. So yeah, that's how we're going to we got our currents, but make sure you check the calculation so that you can do it by yourself. Thank you.